Um, Thanks for having me. Welcome all. I'm going to talk about home automation and Homey, which is something that we use in combination with MQTT. And to tell a bit about it, like a bit of a story, like how I ended up using MQTT and Homey within my home automation setup. So I've been doing home automation since mid 90s. Started with X10. Used a whole bunch of different tools. Some of them good, some of them not so good. Homegrown as well as bought solutions. Started off with Girder, which was a Windows-based application. Really cool. XPL was a protocol. Don't know if anybody heard of it. We stopped the project about 10 years ago, 2014. Domoticz I've used. Home Center by Fibaro. The Home Center 2 was pretty neat, I must say. Home Center Lite had a tendency to crash. Zipabox I used for a long time. I was a member of UPnP. I'll come to the UPnP as well. And these days I'm also running a little bit of Home Assistant if I really can't avoid it. So, as I grew into home automation, I used multiple protocols. First one we used was XPL. Was a very basic, simple protocol, which also made it really neat. UDP broadcast, simple messages. You can see like basic messages here, but it lacked abstractions. Like everything was built into like this one message, and that was it, pretty much. And it was like it turned into a mess, and yeah, it didn't grow with us. It didn't have any security, but because security at the time like was considered like, hey, you have your own network, so security is not required. And there were some technical issues with regards to like sharing ports. Anyway, the project has been put on standstill in 2014, and since then I've been moving on, and then I became a member of the UPnP forum, which is a bit weird because only very big companies become members of these forums, but actually you could. So I signed a 100-page document, put it through a fax, and I became a member. So I was in meetings with Intel, Philips, Samsung, and me. Was an interesting experience, I can tell. But the thing that this very big standard committee was actually open to people wanting to contribute was really cool, really cool. This thing was like UPnP, like it's underlying to DLNA, which is what most people still today they use for video streaming media servers. That's where it's used. So it's still in use a lot. But for home automation, it was too complex. Just look at the list of protocols: UDP, TCP, HTTP, SHTP, GNS, SOAP, and XML. And if you create that in a big mix, you get UPnP. And it was like too much. There were not real libraries to be used. There's only one open source library which is still in use today, but it was for most users it was too hard. It's a C library, so most people like to tinker with scripting language, etc., but there's no support. So it was. Nah, that's people who don't know UPnP that will tell you that UPnP is dangerous. But then again, users typically don't know UPnP as well, so then it might be dangerous. If you know what you're doing, it's a nice technology. It really is. Anyway, this didn't fly either. One of the other things, like no security, was an afterthought. They built it in later, but it was like too late, and so it didn't really fly either. So then I actually resorted to, why don't I buy an off-the-shelf thing? Let's go with it, and then go all the way. I'm going to do one of those cloud-based services. How about that? So, but small device, big cloud. You could configure it only through cloud, and I'm just going to say, like, it worked reasonably well. Once I put too many devices in there, too many rules, then it became a bit flaky. But once it ran, after I made some changes and it restarted maybe, then it was fairly stable. But then it's a cloud server, so like 7 years in, we're gonna terminate this cloud. We're gonna move to the next level platform, fancy whatever. And I was okay. I bought into the cloud, so yeah, okay, that's part of the deal. And so I said, okay, I want to migrate. How do I migrate? No, your box can't migrate. You need to buy a new box. Okay, okay. I'm gonna buy a new box, so I bought a new box. Okay, I have a new box. How do I migrate? Yeah, you had an early one which allowed unlimited devices, but this one actually requires an extra license because you have too many brands and too many devices. Okay, I'll buy a license. So 100 quid, new license. Okay, I have a box, I have a license. How do I migrate? You can't migrate. But I bought a box. Yeah, you have to like manually recreate everything from the old in the new. Like, dude, this is not what you call migration. This is like the front fell off, pretty much. That's what happened. So basically, I was back to square one. I'm gonna roll my own again. And so I wanted to look out like, what am I gonna use? And I'd heard about MQTT, and while investigating MQTT, ran into Homey. Homey is based on MQTT, and then to really like dive into Homey, short intro in like what MQTT is and how it works. MQTT most of all is a publish-subscribe mechanism. Basically, someone yells at the bus, everybody else listens, and you get the message. That's basically what happens. At the same time, it's also sort of like a key value store. So for every unique key, there's a unique payload. And that's how the system works. Now in MQTT, we call these things topics and payloads. And the payload is basically arbitrary data. Can be binary, can be text, can be anything. It's arbitrary. The most common way of dealing with these things is something like this. If you publish something on MQTT, you use a topic. Now, the one thing that immediately jumps out here is the slashes. Because the topics are typically divided in segments, which allow you to organize topics neatly in a tree type structure, and otherwise it would all be chaos. In this case, what we have here, we have a number of topics. This is my home. Clearly there's two rooms, the living room and the kitchen. The living room has two lights, kitchen has a light and a motion sensor, and those have specific values like on 50%, there's motion in the kitchen. Pretty self-explanatory, right? Now, if you're subscribing to this stuff, then MQTT allows you to subscribe to a specific topic, and whenever that changes, you'll get a message. But you can also have wildcards. So in this case, the second one, I subscribe to everything that has a power thing, a power segment within my living room. And in this case, it would mean I would get the messages for both light 1 and light 2 for the power setting. Right? A similar one is this one would, in my home, get every single motion sensor wherever they are, whatever room they're in. And there's another one, which is the hashtag, which you can only use at the very end, which specifies everything underneath kitchen, whether it's 1 segment, 2, 3, 4, whatever. Now from here, there's one more thing, which is retained versus non-retained. It's an important thing because it depends on whether you keep state inside the MQTT broker or not. And the difference mainly is some data actually carries value beyond the current moment. This actually said, like, for example, let's look at this one. A light, the power is on. Once the thing switches on, like in half an hour from now, it's still on. So the value is still correct. It's a state value. That's why we like to retain it. On the other hand, some data actually decays pretty fast. So when I press a doorbell, only that momentary event is interesting to me. Like half an hour down the line, I'm not going to be interested in whether the doorbell was pressed like half an hour ago. It's not interesting to me. That data has lost its value. Similar to if I send a command to a coffee machine like brew coffee, in the moment that's important because the coffee machine has to start. After that, it's pretty much useless. So for each topic that you publish, you can indicate whether you retain it or not. Now, what does this look like? If you look at an MQTT system, then let's see. This is an application, MQTT Explorer, and it allows you to interactively visualize the tree of MQTT topics on the server. And in this case, let's have a look at some of those entries, like for example this one, OpenZWave, used by a lot of home automation folks to control the Z-Wave networks. And you can see there's a very deep structure here. I have the number 1 is my Z-Wave controller. Then there's a bunch of nodes. Each of those nodes has instances. Each of those instances has another number type thing, which has command classes, which has another number type thing, which has a value, which has an ID, which actually has some real data. So this is, if you want to externally understand what's going on here, it's pretty hard, right? You need to really know what this OpenZWave thing is doing, really understand what this topic structure is like. And the painful thing actually is that's OpenZWave, but if I look at the Zipato thing, because I still have that box, but I can't access it anymore, the only way I can access it is through MQTT. And that thing exposes everything it does on a Z-Wave network. But here it looks like this. It's just tons of attributes, and those have specific values, and you have to actually go post messages and collect data to find out what this exact attribute is. So this one's even harder. This is one of the cases, in the we just discussed here about when you use MQTT and when not. This command response stuff, I would not do this in MQTT, but they did. And this also, this sort of explains what a bit of the trouble is with MQTT, because there's so many topics. Now, how do you add meaning to those topics? That's where the real key is. That's where Homey comes in. Now, Homey is not a protocol, but it is called a convention, because the protocol is MQTT, but the convention only is about what is the topic structure? What data do you retain? What data don't you retain? How do you deal with those? And this is straight from the website. And the crucial things here are these. It's a standardized way of services and devices to announce themselves and their data on the MQTT broker. And it allows for automatic discovery, configuration, and usage. That's what it does. So how does it do that? Oh, this is the obligatory one, obviously. There's yet another one. The good thing is that XPL already died, so one competitor down. UPnP is out the window as well, another competitor down, so we're slowly getting there, I hope. A Homey device basically is made up of 3 components. One is the device itself. Then it has a list of nodes. Each of those by the way, has metadata, so the device with metadata, nodes with metadata, and each node has a number of properties with metadata. This is the basic structure of every Homey device. And if you map that onto MQTT topics again, in this case we have a device which has an ID supercar, that's an example, and it has a number of attributes, state, Homey, name, nodes. State is an important one, because that actually that thing indicates where the device is in its life cycle. The most common ones you'll see with Homey is init, which means I'm alive, but I'm not ready yet. There's ready, which means I'm operational, you can send me commands and I will publish data. And sleeping, which for battery-driven devices, which basically says hey, I'm still here, but I'm currently sleeping. I'll get to you when I wake up. And then there's some others, but these are the most important ones. The Homey version, of course, otherwise you don't know what you're working with. And the last one is the most important one for the device, is the list of nodes that it contains. And in this list, each of the nodes listed is actually the node ID again. All of these, as mentioned in the bottom right corner, are stored in a retained manner. So whenever you query your MQTT, you subscribe to a topic, you get the description of the full device. A node, one of the nodes, each of the nodes in a device, that can be 0 or more. So you don't need to have a node, you can also have a device without anything. We'll see an example later. Similar topic structure, just we have an extra segment, which is now the ID of the node. Has attributes as well, name type, and again, list of properties, similar construct. In this case, it lists property IDs. Obviously, the next slide, very easy to predict, properties. Same thing again, extra level, temperature, and there's going to be a number of attributes, but these one are actually add a bit more meat to the whole convention, because it gives you a name, but it also tells you whether it's settable, which means either it's a sensor, it produces data, or it's settable where you can actually set a command or set some configuration data, whatever you want to push there. Then there's units, the data type, format, in this case it's -20 to 120, that's degrees Celsius for engine temperature. That's the range in this case. And then the temperature itself is posted on the actual topic of the property itself, which contains the value. Now if you want to control devices, this is it's set up in a way that you can actually use the MQTT subscriptions in a way that actually makes it easy to actually find the data that you need. And this is one of the key things, in my opinion, you have to do with MQTT, is properly design the topics such that querying the data you're looking for becomes easy. Whereas in with SQL databases, is typically you normalize data because that's how you structure. You want to deduplicate. Whereas with this type of thing, not necessarily you don't deduplicate, but you really design it in a way that with a subscription, you get the data, you can query the data based on the subscription to only get what you want. Now, the examples we have here, if we subscribe to the state property for each device, basically it will give us a list of devices that are on our network, or MQTT broker. The 3 pluses will deliver me every single property value that's in the system, with the IDs of devices, nodes, and properties, because that's in the topic name. If I subscribe to the supercar ++, I'll get every property value of only the supercar thing, right? Setting, I already briefly mentioned on a previous slide, like there's a settable topic, and if a property is settable, then there's a /set topic where you can actually post your data, and that's for the property to actually pick up the value and do whatever it needs to do with them. So let's look at the use case. Ventilation system. When I bought my new house, it's not that new anymore, 7 years ago, a WTW, warmte-terugwin unit in Dutch, or it's a balancing fan with a heat exchanger. The thing had a single input for, I could either control it like running at a specific percentage or by a carbon dioxide level, but it required a very expensive sensor, and only one, because I wanted to control 4 rooms, and I already had this weather station. It's a NetAtmo weather station, but it also measures carbon dioxide, and the extra units are like, I don't know, like 20, 30 bucks, I think, an extra unit. So they're pretty neat for indoors. I already had this thing coupled on the Homey bus that I created. And here we can also see like the things that I just described in like device nodes properties. So if we have the Homey namespace here, you can see there's the NetAtmo device, which has 5 nodes, 3 additional indoor modules, the main one, and an outdoor module. And in each of those nodes, we have properties, which is, for example, battery level, and here is carbon dioxide level, 858 in this case. Since I have this data on my Homey network already, I wanted to use that data, of course, and not buy very expensive carbon dioxide and put wiring in, because it was only wired, it wasn't even wireless. I wanted to use this. So I had to come up with something. ESP32. Very dangerous devices, was the first one I created. Very addictive. Once you start creating those things, you really want to automate everything that you can get your hands on, because this is really fun stuff. Anyway, The module on the left is the ESP32 microcontroller. The module on the right is a piece of hardware that, because I needed a 0 to 10 volts input on my van, and ESP only has 3.3 volts, you can't control it like that. So I need an extra hardware unit that can convert pulse width modulation signal to a 0 to 10 volts. This is just off the shelf, buy it on Amazon, it's just a couple of bucks. It's really cheap stuff. So what I built, I had the MQTT bus, created a Homey device logically in my ESP module. There I send out a PWM signal, and then the hardware did the 0 to 10 volts. And that's where the connection to the ventilator was actually, and it worked. But now I have this thing also connected to Homey, but I haven't connected the two yet. Oh, here's one more thing. This is the code. Don't try to read it. It's a really small print. The essence of this slide is only that, considering that I would have controlled the thing through MQTT anyway, the only code I needed to write to get it into Homey was 25 lines of basically plain text, almost, just describing the device, its properties, etc. So this was the only addition that I had to make it a Homey device. I'm sorry? Yeah, just a metadata. So once we had Homey up, now we need to connect the two. So Node-RED to the rescue. Node-RED is a engine that you can use. It's really cool. It allows you to create flows with all kinds of functionality. What happens is a message, an event comes in, it starts a flow, and basically visually you can follow the lines, and it moves from one block to the next and creates an input and an output. There is an integration with Homey. You can see it on the left here. Here are the building blocks that you can have for Homey. And you can see here, there's 4 blocks on my canvas that all have carbon dioxide levels. So once you configure it, you drop the box in here. You select the device. In this case, I select the device NetAtmo to Homey bridge, which is the one I had. Within the device, you select the node, additional node module for Noah, which is my daughter. And the last one is the property carbon dioxide level. So once I have this connected, messages of the 4 nodes will start flowing and hit this function node, which is nothing but calculate the maximum value. So whatever the value is in any of the rooms, I only want to take the maximum because that's what I want the fan to respond to. Then I pass it only when it changed, because it doesn't change, I don't have to put it on a network. And then I have an outgoing one, also a Homey one. And in this case, I'm sending it to the Homey node. So effectively, I'll listen to MQTT topics, do some magic, create send another MQTT message to the fan unit. And this thing works. You can just pass it on. You can see on the left-hand side we have in the blue box, it's very small print, 1023, 459, 483, 389. And on the right-hand side we can see the maximum, which is 1023. And this is what it sends to the box, and it actually works. So all of that's really, really cool. But then I could have done this with just plain MQTT. Why would I need Homey to do this stuff? I could have just connected the two and I could have been done with it, and why all the hard work? The trick is that because if you typically look at what a home automation system looks like, they all look like this, except that they're all black, because they're black boxes in general. Every one of them, basically, centerpiece is a message bus. Then there's a logic engine like if this, then that. There's a mobile app, there's a web UI, and there's a ton of hardware drivers. All of them. And it's a very big duplication of effort. If you use Home Assistants or OpenHAB, they pretty much support like 80-90% of the hardware drivers are duplicate. It's just duplication of effort, like what they do with one supports it, the other also supports it. You just have to write the code all again to create those drivers. Logic engines. For example, the Home Center 2 for Fibaro, you can code it in Lua. Has a visual language, not really nice. Zipato only does the visual one, but doesn't have a scripting language. And so, if you buy one of those, if I buy into the Zipato scripting engine, I'm also stuck with the Zipato app. Because it's one box. I can't control the Zipato box without the Zipato app. That's how it works. Now, if you take this box apart into its components, we can actually start mixing and matching those underlying components. Instead of being stuck with one of them, we can use all of them. And I'll give you a brief overview here, because this is the Node-RED that I just showed. But what I also use is Domoticz. It's an older platform. It's still being maintained on a bit of a low level, but what I really like about it is that I'm a Lua guy. I can script it in Lua. I connect it to the Homey bus, and now I can use Node-RED. But if I want to use the scripting from Lua, I can also use that, because I can just connect Domoticz. If I don't want that, I can, like for example, I can use, I like this one as well, Blockly. You can use Blockly. It's also in Domoticz. Now I can use Blockly with Homey. As long as you connect the stuff together through Homey, you can like mix and match all the tools you want, really like. There's one more I already mentioned that we had. There's no need to actually have devices or have nodes. So this influx controller, for example, has no nodes. It's only present here. It only shows itself. But what the thing does under the hood, it will subscribe to every property that's on the Homey network, and it will stuff it in an influx database. If you don't know what influx is a time series database. Top-notch tool, open source, freely available, anyone can run it. And you can create fantastic dashboards with that data. So I am not stuck with any of the graphing of Domoticz or Node-RED or whatever, because I can simply use InfluxDB to create the dashboards that I like. If I don't like InfluxDB for dashboards, I can connect Grafana again to Influx. Grafana is like industry standard IT monitoring tool with alerting everything you ever wanted. So for example, the NetAtmo displays, this data is just gathered from, because NetAtmo drivers drop it on the Homey network, it's automatically consumed and passed into InfluxDB. And I can slice and dice the data any which way I want. So here I have the carbon dioxide levels in the 4 rooms that I'm monitoring over the past 7 days. Temperature in the room. Clearly a dead battery on the left-hand side, which has been replaced. And yet another one is, for example, is energy usage. Top one is natural gas that I use at home. You can see it's getting colder because we're using more gas. Electricity in and out. Electricity per phase. Solar panels. I can just use whatever tool I like. Not because I'm stuck with one of those specific tools, with one of those black boxes. I can like mix and match the tools that I like. And that's the real use case that Homey enables, is setting you free of all those black boxes and actually allows you to use best of breed tools. I don't even know where we are in time. Half an hour, clearly in time. So this is basically mixing and matching. Work in progress. Homey version 4 is the one that we currently have. Homey version 5 is almost done. It makes changes because if you have quite a big home automation setup, the number of topics that you have to scan is going to be quite hefty. And that's why in Homey 5 we changed it from the descriptions. Can I have a quick look? Here, because we actually have a bridge. That bridge is Homey 4 to Homey 5. And I can see, for example, in NetAtmo, you can see that the description is now a single JSON blob that has all the data. And then the number of descriptions that we find down the tree is actually only the actual data and no longer the full description of everything that we need.
Okay, it's pure data that you can get all the data at once.
Sorry?
You can get all the data at once you want.
Yeah, at least the device description, like the description, like what methods it has, what properties, what nodes, which is settable, what's not. All of that description is in a single JSON document now. So that makes it a lot faster to parse. I think in the big setups we saw like 70% reduction in startup time of a controller to actually collect all the data from the network. So that's really neat. Another one is child devices. But sometimes you model, like if you have a Z-Wave bridge, for example, you have like 10 switches, but there's one master device, which is actually the Z-Wave bridge. And then you have 10 sub-devices, which are the actual devices, the switches that you have built into your house. And Homey version 5 will actually allow you to have child-parent relationships to do that. Another one is the neat one is logging, especially for the ESP type devices, because they're like typically headless, but they allow you to log onto MQTT topics, such that the central MQTT controller, Homey controller, can actually pick up those log messages and actually put them into a syslog or print them on a console, whatever you like. Really interesting. The last one, but this is really early stage, is device capabilities and profiles. Because if you want to model like a light that you can dim, there are a lot of different ways that you can model that same light with properties and nodes. And to create a bit more standard structures for those, we're trying now to like get started with like device capability profiles, such that if a device is a light, it can simply say like, the type I am this specific type, and then every controller knows this is what I can expect. If I set it to, when I set the device to 1, it won't go off, it will just go to the lowest possible dim state, for example. If I set it to 100%, it's not 0 to 255, it's 0 to 100, like similar capabilities across the board. If you announce that you are supporting this specific profile, it's similar to, I guess, like Bluetooth profiles, similar type things. Maybe not the best analogy considering Bluetooth, but you know, as a user, you know what you can expect from the device once it supports that specific thing. And that is the end of my talk. Thank you very much. Any questions? Yeah, please use the mic for recording.
Okay, for me it's new.
Can
Homey?
you put it a bit higher?
Yeah. For me, Homey is new, but apart from a convention, it's also a standard.
Mm-hmm.
So, what support is there for this standard, and do all kinds of devices support this?
No, there's a few devices that support it. It's usually tinkerers that work with it. If you build your own devices, then it's a really good solution. Hopefully at some point we'll get to a point where we can actually like build an integration with like Home Assistants or OpenHAB, so you can actually tap in all the devices that they already have and open them up. But that's not where we are today.
Okay, thank you.
Yeah.
Next question about the first question. Is it possible to create it yourself? For suppose you have a device which doesn't support Homey, and you can implement the Homey protocol on that device yourself in some way.
Yes, implementing a Homey. The question is like, can I implement a Homey protocol myself on a device?
Yeah.
As long as you can control the device software, typically you can, because Homey is a convention on top of MQTT. MQTT libraries are available everywhere. Every possible platform pretty much has MQTT libraries and everything. And then all you need to know is like the 25 lines of code I showed is like pushing those topics out.
Oh, you did it already, eh?
Yeah, pushing those
yeah.
topics onto the MQTT bus, and that's where you announce your device.
Yeah,
that's one of the strengths is that it really only uses industry standard. We don't define our own connections or TCP protocols. It's all handed off to MQTT, and that's just an industry
standard. You can
standard.
do it ad hoc, so to speak. You have a device which doesn't support it, and you can just build something
in your own devices.
Adds the metadata. And
if you have your own devices, it should be fairly easy. If you already do MQTT, it should be fairly easy to update them to also do Homey.
Yeah, okay.
It's really not that hard.
Cool.
Hi, I'm Frank. Short question. If I look at the device schematics you showed, or the topic schematics, the top one is device or service, and then it goes into like a node. But I noticed when you showed NetAtmo, the devices are actually the nodes, but not like the top level. So what is a node then, and what is a device? Which
that was the exact reason that we have introduced child devices in. Because the example I gave, like a Z-Wave controller and the Z-Wave devices, but the NetAtmo thing is the exact same thing. You have a NetAtmo like driver that gets the data, and then you have the underlying devices. Right. So if we want to properly model them, we should model them as child devices that live within a parent device, which is a gateway.
Right. Okay.
So that was the exact reason, but very well spotted. Very well spotted.
Okay.
Yeah.
Anyone else?
Anyone else? Oh yeah, there's another question.
Yeah, I have a question. I'm fairly new to the IoT stuff.
Can you speak up a bit louder?
Yeah, sorry. I wonder how does your Homey system relate to another open source system I've heard about, Home Assistant, which seems to be providing pretty much the same kind of facilities.
It provides the same. Actually, it provides far less facilities. Because the Homey, the question is like, how does Homey relate to other like out-of-the-box open source solutions that do a whole bunch of things, and how does it compete with them? Homey is only the bus part, basically, of these home automation solutions. And that's also why if you want to use Homey, you have to run your own MQTT server. So this is not for just everyone. You have to be at least a bit tech savvy to spin up a Raspberry Pi and set up an MQTT server. If you're running already your own like Home Assistant at home, you should be capable of doing this. What Homey really brings to it is that it allows you to bridge between the different systems and allow you to use multiple systems at the same time for whatever the best features are they have. But it's Homey in itself is not a standalone all in out-of-the-box system. It's not. It's just a message bus, and you have to tinker yourself with connecting the other parts to it.
Okay.
Does that answer your question?
Yeah, I think that's good. Yeah. Anyone else?
Now we're done. Thank you very much.